Right now, a telescope drifting in the cold silence beyond the moon has captured images that force us to confront a truth we have spent centuries avoiding. The universe is not simply large, it is so vast, so violently immense, that the portion we can ever hope to see is vanishingly small, an infinitesimal speck within a reality that may have no edge at all. The James Webb Space Telescope has looked deeper into space and further back in time than anything before it. And what it has found is not comfort. It is scale so overwhelming, it borders on terror. If you are ready to feel how small we truly are, stay with me. To grasp what Webb has revealed, we must first let go of the illusion that the universe is something we can survey like a map. Space is not a container we peer across. It is a living, expanding fabric, and every direction we look is also a direction backward through time. Light moves at a fixed, merciless speed, 300,000 kilometers every second, fast enough to circle Earth 7.5 times in the blink of an eye. Yet even at that velocity, distance becomes delay. The sunlight warming your skin left the sun 8 minutes ago. The light from the nearest star beyond our own took more than 4 years to reach us. When we gaze at the Andromeda Galaxy, we see it as it existed 2.5 million years before any human walked the Earth. Every star in the night sky is a postcard from a different epoch. The deeper into space we look, the older the message. But the universe does not deliver these messages unchanged. As space itself stretches, it drags light along with it. Wavelengths lengthen. Violet becomes red. Red slips into infrared, and the brightest events of the early cosmos arrive dim and disguised. This redshift is not a trick of perspective. It is a direct measure of how much the universe has grown since the light began its journey. To see farther is to see earlier, and to see earlier is to watch light fight against an ever-widening gulf. For generations, our best telescopes were tuned to the narrow sliver of light visible to human eyes. They showed us breathtaking beauty, swirling nebulae, colliding galaxies, exploding stars. But as we pushed toward the cosmic dawn, the view dimmed. The first galaxies emitted fierce ultraviolet fire. But by the time that fire reached us, expansion had stretched it beyond the reach of visible light instruments. Vast populations of ancient galaxies were not missing. They were simply speaking in a frequency we could not hear. Webb was built to listen in that forgotten tongue. Its golden mirror, wider than any flown before, gathers infrared light with exquisite sensitivity. It floats 1.5 million kilometers from Earth, wrapped in a 5-layer sunshield that keeps its instruments colder than the shade of Pluto. Only at those temperatures can it detect the faint whispers of photons that have crossed billions of light years without being drowned out by its own heat. When Webb stares at a patch of sky that looks utterly black to every previous telescope, it does not see emptiness. It sees crowds. In regions that should have been nearly dark 300 to 500 million years after the Big Bang, Webb finds galaxies already blazing. Some are surprisingly massive. Hundreds of millions, even billions, of solar masses packed into systems that theory said should still be fragile seeds. Their stars burn fiercely, forging heavy elements at a startling pace. Their central black holes weigh millions of times the mass of the Sun, when the universe was barely old enough to allow such monsters. These are not rare outliers. They appear again and again, forcing astronomers to confront a universe that assembled itself with unsettling speed. One of the deepest images ever taken shows a tiny patch of sky, no wider than a grain of sand held at arm's length. Within that speck, Webb resolved nearly 800,000 galaxies, each one a city of billions of stars, each one separated from us by billions of years. If we printed that image at the resolution of the famous Hubble Deep Field, The sheet would be 4 meters on each side, a wall-sized portrait of cosmic abundance. Scale that patch up to the full sky, and the observable universe may contain not hundreds of billions of galaxies, but trillions. Trillions of islands, each potentially orbited by billions of worlds, stretching in every direction as far as light has been able to travel in 13.8 billion years. Yet even this staggering number describes only what we can see. The true terror lies in what we cannot. The observable universe is not the universe. It is merely the sphere of light that has had time to reach us since the beginning. Its radius is not 13.8 billion light-years, as intuition suggests, but roughly 46.5 billion light-years, 93 billion light-years across. This paradox arises because space itself has been expanding while the light was en route. A galaxy whose light left 13 billion years ago is now far beyond that original distance, carried outward by the stretching of the cosmos itself. Imagine points marked on the surface of an inflating balloon. None of the points move across the rubber. The rubber itself grows, and every point recedes from every other. The universe behaves the same way on its largest scales. There is no center, no special direction, no edge within the portion we can observe. The cosmic microwave background, the cooled remnant of the Big Bang, appears almost perfectly uniform in every direction. A smoothness that would be impossible if space simply stopped just beyond our horizon. Therefore, space continues. Galaxies continue. Entire duplicate cosmic webs, perhaps infinite in extent, lie beyond the reach of any signal that could ever arrive here. Light emitted today from a galaxy 50 billion light-years away will never reach us, because the space between us is expanding faster than light can cross it. That boundary is not a wall, it is a horizon, and it is receding from us even as the observable sphere grows. Some regions that are barely visible today will fade forever in the future, their light stretched to infinite thinness. This accelerating expansion is driven by dark energy, a repulsive force that behaves as if it has negative pressure. It makes up roughly 68% of the universe's total energy content, and unlike matter or radiation, does not dilute as space grows. Its density stays constant, so as the universe enlarges, the total amount of dark energy increases, driving ever faster expansion. In the past, matter dominated. Gravity sculpted galaxies and clusters. Today, dark energy rules, and its reign is absolute. Without dark energy, the observable universe would be far smaller, perhaps only a few billion light-years across. Vast tracts we now see would remain forever hidden. With it, we glimpse a richness that only underscores how little we truly perceive. In the far future, hundreds of billions of years from now, every galaxy beyond our local group will have crossed the horizon. Future astronomers, if any exist, will look out on a sky containing only the merged remnant of the Milky Way and Andromeda, surrounded by darkness. They will have no evidence that trillions of other galaxies ever existed. The cosmic past will be erased from view. Even today, measurements of the expansion rate refuse to agree. One method, using the ancient microwave background, yields about 67 kilometers per second per megaparsec. Another, using nearby supernovae and variable stars, consistently returns around 73. The discrepancy, known as the Hubble tension, has survived every attempt to explain it away. Webb's ultra-precise distances have only sharpened the conflict. Something in our understanding is incomplete, either an unseen systematic error or new physics lurking in the dark sector. Dark matter provides the counterweight that allows structure to form at all. It outweighs ordinary matter 5 to 1 and feels gravity but almost nothing else. It clumped early, forming vast invisible halos that ordinary gas later fell into, cooling, collapsing, igniting into the first stars and galaxies. Webb traces these halos indirectly through the motions and distributions of the galaxies they cradle. The cosmic web, filaments hundreds of millions of light-years long, threaded between cavernous voids, is the visible signature of dark matter's invisible scaffolding. Stand inside one of those voids, and you would see almost nothing for tens of millions of light-years in any direction. The universe is both densely crowded and achingly empty, a contradiction held together by forces we cannot directly touch. Webb's deepest fields capture both extremes in a single frame. Rivers of galaxies blazing along filaments, and yawning black abysses where gravity never won. All of this, the trillions of galaxies, the 93 billion light-year sphere, the accelerating horizons, the invisible scaffolding, converges on a single, vertiginous realization. We occupy an infinitesimally thin slice of space and time within a reality that may be boundless. Every observation Webb returns is a reminder that the universe does not revolve around us. It barely notices we are here. The light we see tonight left its sources long before Earth formed, crossed distances that dwarf human comprehension, and arrived just in time for a fleeting species to catch it before much of it slips away forever. If this vision of cosmic scale has shaken you, if it has left you staring at the ceiling wondering how anything can matter in a reality this immense, then subscribe for more glimpses into the abyss. Comment below with the single thought this leaves you with. Share this with someone who still believes humanity sits at the center of anything. And ask yourself, quietly, in the dark, in a universe this vast, this indifferent, this beautiful, what is the meaning of being here at all, able to witness even a fragment of it?